chemistry revision, UCE, paper 1 chemistry, 2025. Teacher Navasa at the River for International. We give you the best. Today we want to look at item 2. In the previous video, we looked at item 1. And now we are going to look at item 2. So this is what we are going to do. Let's read through it. This is our item that we are going to do today. And it reads, Mary, a 60-year-old. Mary, a 60-year-old, complains of dental caries. We are going to highlight that. Joint pains and muscular cramps. During one of her visits to a hospital, the doctor advised her to drink water from a borehole because it contains a compound that can solve her problems. Mary would like to know more about the compound and has approached you for assistance. Your chemistry teacher told you that the compound is chemically written as this, as XY2, where X and Y are not the actual symbols of the elements. The teacher further informed you that X belongs to group 2 and period 4, while Y belongs to group 7 and period 2 of the periodic table. And the figure 2 shows a periodic table of the 20 elements. What is our task? Our task number 1 says, let's bring it closer here, that explain the nature of substances X and Y and identify them. Now we have started the chemistry. So we have a sample of a periodic table here, as you can see. It has from hydrogen and it even goes up to argon. But the first 20 elements are going up to calcium. So what was the description so that we identify them? What we want to do, we want to know what is X and then what is Y. Let's start. I am going to say, they have said that the teacher further informed you that X belongs to group 2. So where is group 2? This is group 1. This is group 2. Okay? And then, so what I can do to be able to identify, I can draw a line like this. It goes through. Then they are saying, and period 4. So what is period 4? This is period 1, period 2, period 3, and period 4. So I can draw a line. So you can realize that the element they are talking about is calcium. So I'm going to come here and say X is calcium. Let's go to Y. They have said that Y belongs to group 7. So since it is group 1, group 2, this will be group 3, this will be group 4, group 5, group 6, and this will be group 7. So I will draw my line like this. They also said that it is also located in period 2. So this is period 1, this is period 2. So what I'm going to do, I'm going to draw my line like this, then I see. So you see where they have met, where they are forming a cross, it is fluorine. So I'm going to come and say, oh, actually, our Y is called fluorine. So what are their nature? Number 1, we are going to start with calcium. So we are going to say that X is calcium, We want to explain its nature. In group 2. Or what I can do, or what I can do, I can say that calcium is a metal. Now, if you have understood very well the periodic table, you can remember that calcium is an alkaline earth metal. We have now identified it. Why? Because reason number one, we know that elements which are in the following groups, which are in group 1, group 2, and group 3. 1, 2, and 3. All these ones are metals. That's why we are saying they are metals. So, reason number one why I'm saying it is a metal, I'm going to say because it is found or located in group 2. Group 2 of the periodic table. That is not the only thing that gives it, but also when you look at its electron configuration, remember it is element number 20, and therefore its electron configuration, it is 2 to 8 to 8 2. So when you look at these two, it also identifies a metal. Remember, a metal in bonding, it releases its outermost electrons to make sure that it is stable. So number 2, I will say because it also loses its, or I can say it has 2 valence electrons. Valence electrons. That one makes it a metal. It's an electropositive. It releases, so that one makes it a metal. I can go ahead and talk about the period where it is located. All this I'm trying to describe the nature of calcium. Let's go to fluorine. That was 1. Let's go to fluorine. Fluorine. Now, fluorine is a non-metal. Why are we saying it's a non-metal? Let's come back here. Since group 1, group 2, group 3 are metals, we know group 4, they are metalloids. We call them metalloids. Others call them semi-metals. Okay? Then we have group 5, group 6, group 7. All these ones are non-metals. Then we have group 8, which are inert. These are inert substances, inert gases. All these ones, neon, argon, all these ones. So that's why we call it a non-metal. Why? And also number 2, why it is a metal? For it is element number 9. If you can see it in the periodic table, it's element 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So therefore, its electron configuration becomes 2 to 7, which means that its outermost shell lacks 1 electron. And therefore, I can say it is a non-metal in a halogen. Remember, group 7 elements, we also call them. So I could have even said it's an halogen non-metal, a halogen in group 7. Okay, I'm explaining its nature. Lacking, or with 1, lacking 1 electron to fill its outermost shell. Okay, so that is what I can explain. That is how I can explain it. But maybe when I talk about those ones, those of you who missed the lessons of electron configuration, you can forget this. But let me show you. Let me show you. Calcium being 20, it means that in its nucleus, it will have, of course, protons and neutrons. So in the first energy level, it will have 2 electrons. In the second energy level, it will have 8 electrons. Okay, like that, like that, like that. And then in the third, it will also have 8 electrons. So we have 2 plus 8, those are 10. So this becomes, if I add 8, it becomes 18. And then lastly, in the last energy level, which most of us call valence shell or valence energy level, we have only 2 electrons, which make a total of 20. And when you count fluorine, it has 7. It means in its nucleus, it will have their protons and neutrons. In the first energy level, there will be 2 electrons. And then, because it is 2 to 7, now in the second energy level, it will have only 7 electrons, which means it is lacking 1 to get full. This is 2 to 7. This is 2, which is this one. 2, 8, which is this one. 2, 8, which is this one. To 2, which is this one. So this is what I was talking about, that it loses. So for this to be stable, its outermost shell must be fully filled with electrons. But you can see in the last one, it has 2. So for it to be stable, it has to release these 2, and then it is able to be stable. Now for this to be stable, it needs 1 to make 2 to 8. So it needs 1. So that's why I've said it lacks 1 electron in the outermost shell, and I've said this one, it loses, or it has 2 valence electrons in the outermost shell. That is how I can simplify this. But we will look at that later when we are answering another part. So let's now go to part B of the question, which requires us to describe how X and Y form the compound. Let's go for it. Now, we have already identified that X is calcium, okay, which we have identified as a metal in group 2, which are also called alkaline earth metals, okay, earth metals. Then we have also identified that Y is fluorine, which is in group 7, and we have said it's a non-metal. Now, we are going to start by identifying what compound are they going to form. They already showed us here. They say that they will form a compound which is like XY2. Now, let's first form this one. This is calcium, and this is fluorine. It has 1 valence. This one has valence 2. So when they close, this comes here, this comes here. So which means our formula will be calcium fluoride, like this, which is XY2. So we have already formed this. So describe how X and Y will form a compound. Number 1, how are they going to form compounds? So we are writing, say it will form a compound by calcium losing its two valence electrons to fluorine to form calcium fluoride joined by a strong ionic bond. That is how they are going to be formed. Because calcium, like I showed you, it being a metal, it will lose 2 electrons, and then fluorine will receive them. Now you realize in fluorine we have 2. There are 2 fluorines, which means, and this one has 2. So this one will take 1 electron, and this one will take 1 electron, just like we are going to show in the drawing. But let's first draw the drawing, like I said. So let's see how it is formed. And of course, this is going to be an ionic. Is going to be an ionic compound because it is between a metal and a non-metal. So let's see how they are going to form. Now we are going to start with calcium itself. Then we are going to draw like this. We have protons, we have neutrons. The first energy level takes 2 electrons. The second energy level will take 8 electrons. The third energy level will also take 8 electrons. And then the last energy level will also take 2. So I have 2 plus 8, 10, plus 8, 18, plus 2, 20. So we have 2 plus 8, which is 2 plus 8, 10 plus 8. Yes, which is 18 plus 2, which is 20. Now, we are going to come, this is 20. We are going to come to fluorine. Remember, there are 2 fluorine atoms. So we are going to have 2, which means we are going to have 1 here. It has protons and neutrons. Then the first energy level will have 2 electrons. And then the last energy level is going to have 2, 2, 2, 2. Those are 6 plus 1 here. Then we are also going to have another one here. Protons and neutrons. Then we have 2 electrons. Then we have 2. Okay. Then we have, so this is a fluoride. This one is also a fluoride. So what will happen is that 1 electron here will be transferred here, and this also here will be transferred here. So here we have all of it, which means when this one loses, the outcome will be, we are going to have this calcium itself when it has lost. So which means I am going to have protons and neutrons. I will have 2. Then I will have these will be 8. These will be 8. Then I'll also have the last one with 8. So which means here I have lost 2. So in other words, here I have formed a cation, which is a calcium plus. So I can even decide to circle it like this. Then I also have these 2 which have been formed. 1 calcium, protons and neutrons. Now I'm on fluorine. These are 2. And then the last one, we'll have the outer shell also full. You get? So this one is also going to be a fluoride ion. Okay? Then also here I'm going to have another one, protons and neutrons. Then I'm having this one, and then also 1, 2, 1, 2, 1, 2, 1, 2. So this one is also going to be another fluoride ion. In other words, this structure that I have formed here, this one is what I call calcium fluoride with 2 fluoride ions and a calcium ion here. Now, this is the ionic compound I was talking about of calcium fluoride. A metal losing its 2 valence electrons to the what? To 2 fluoride atoms of fluorine. One here and another one here, like it has been seen here. But if I want to combine it together, that is what you form. So this is the calcium fluoride with a cation of calcium 2, like that, like that. So we are going to look at another part. Let's first keep this one. On part C, they want us to talk about the properties of the compound formed. Remember, the compound that we formed the other side was calcium fluoride, which we said it was an ionic compound. So now, basically what they want you to explain or describe the properties of ionic compounds. Number 1, ionic compounds have high and they have high boiling. They have high boiling points, but also and melting points. Why? Because we want to explain. Because there is a strong bond. If you remember here, there is a strong bond. There is a very, very strong bond that is holding these two. There is holding these two that has been formed. So that is one of the reasons why it is very high. Number 2, it is a solid substance. It is also a very solid substance. When you come to conductivity, why we are saying it is solids, it is of course ionic compounds are going to be solids due to the lattice that has been formed between the two, that lattice that is formed. Then when you come to electricity, such substances they conduct current or electric current in molten state, but in solid state, they are not, they are bad conductors. So in solid state they cannot conduct, and this one is very simple because in solid state the particles are close together and they are locked together. But if they are put in molten state, now the ions are free to move and conduct from one place to another. And maybe which other one can we talk about? After, since it has been formed from, as you realized in the area, it is a very stable compound. Why is it stable? Because both ions, that is the calcium 2 ions in the state, and then the 2 fluoride ions, all are in stable states. Because remember, calcium 2 ions is 2 to 8 now, and then 1 fluoride ions is 2 to 8, and also another one is 2 to what? 8. So you can see all the outermost shell electrons, the most shell of electrons is full, and therefore is very stable. So those are some that we can highlight here. How does the compound address Mary's challenges? What were Mary's challenges? Let's come back to Mary's challenges. What were the challenges of Mary? What were the challenges of Mary? Let's look at them. 1, dental caries. Dental caries just simply means dental decay, like decaying. You have some holes in the teeth. Then you have joint pains. She also complained. She also had masseter cramps. And now, after understanding the component, we have realized that the component is basically calcium fluoride. Now, which means here, there is a source of two things. There is a source of fluoride ions, but there is also a source of calcium ions. So when we come to dental caries, we will say the compound provides calcium. And what is the importance of calcium? That strengthens bones, even the joints, because remember on the joints there is also another layer of cartilage which helps in reducing friction. So it strengthens bones. Even calcium is used in the formation of bones, and therefore it will reduce on joint pains. So this calcium will be able to solve the problem of joint pains. That is one. Number two, this substance will also provide fluoride ions. Now, all of us who uses any of the toothpastes, these toothpastes actually have fluorides in them. A fluoride ion, you see there is a fluoride in them. And what is the importance of fluoride? Number one, the fluoride prevents fluorosis, or the dental decay. Now, these are two big main points. Fluorosis is the damage of even bones and also teeth. But the dental decay is now what we are talking about, the dental caries. It prevents them. But in number two, it prevents attack of acids to the teeth. In other words, there is the way it makes the enamel, the one I will call enamel, very strong and resistant to what? To acids, and therefore it will not easily be attacked. So you have calcium, even muscles, the calcium will solve them. Fluoride will prevent teeth from one, dental decay, but also fluorosis, then attack. But think also the same thing with bones, fluorosis also for bones. And then maybe lastly, we look at the write down one impact of having a lot of this one, which is calcium fluoride in the environment. I think number one, if they are excess in the body, they can actually also cause fluorosis. Okay, how can we prevent this? Preventing this, you regulate usage. You don't overuse. Regulate usage. Number two, we can have water pollution if used in excess. When you are writing your answers, you have to make sure that you state excess. If they are used in excess, then you can use water pollution. Now, this one has very many ways. One, you regulate, you avoid discharge. You avoid the discharge of any industrial materials or industrial wastes before they are being treated. So which means another one is treating what? Is treating water or treating industrial waste before it is discharged in water. Now, the most very interesting thing is about hard water, hardness. These they can have an impact on the hardness of water. Remember, hardness of water is caused by magnesium ions or calcium ions. So you realize that we have calcium in this. So there is a high chance, much as this substance is not too soluble, but it's just that you have some calcium ions that are going to go now enter into the system, and at the end of it all, they are going to cause water hardness. Number four, you can also look at the pH. The pH. Remember, once calcium gets into the environment, it can easily be able to combine with bicarbonate, and therefore this bicarbonate can end up there making calcium carbonate. And you know, once this is formed, we can easily now this one break down, and calcium you easily react with water. So you can easily increase the pH, which means you will make soils more alkaline. Okay? How can we do this? We ensure that we always monitor the amount of calcium in soils which are near. But also, you will continuously measure the pH of the soil. These are some of the points, the highlights, which I think can give you or have given you an idea on how you would have or you can attempt such a question. Now, I think for now, we can say that is what we have done. And then next time, we'll be able to check on item 3 and 4. So otherwise, we wish you well. If you have any questions that you would want us to answer, kindly send them to our number shown on the screen. Thank you very much.